Hello, my name is Matthew Johnson. This is FTT 122, Introduction to Ammunitions and Basic Ballistics, Week 6 assignment. Today's date is December 22nd, 2024. For today's assignment, I will be discussing trajectory and sights, gyroscopic drift, drag, Magnus effect, Coriolis and Eötvös effects, vertical angles, and transonic ballistics performance. First, we have trajectory sights. In order to hit a distant target, a rifle must be correctly sighted in, and to accomplish that, the shooter must have some working knowledge of the bullet's trajectory. Sighting in a hunting rifle to hit a certain number of inches high at 100 yards or 100 meters maximizes the point-blank range of the rifle and cartridge and is superior to zeroing at a fixed distance like 200 yards. The system maximizes the distance in which no holdover is necessary. Of course, the actual distance the bullet should hit above the point of aim is 100 yards or 100 meters, which is about 108 yards, various of the individual caliber and load. Gyroscopic drift or spin drift or gyroscopic drift is a phenomenon caused by the right hand twist in or our barrels. Due to the right hand twist, the nose of the bullet tends to offset slightly to the right during flight. The effect is that even under zero wind conditions, the bullet will impact to the right of the center. The effect is more pronounced at ranges beyond 600 yards. The effect amount for a specific bullet is difficult to calculate mathematically, but it can be done. The calculation is based on the stability factor of the bullet, the time flight, the speed of the twist, the physical length of the bullet, and their air density. Drag. The greater the bullet's drag, the longer it takes to get to its target and the more it can be impacted by external forces. The major concern is the impact to elevation, which affects the bullet's vertical path, and windage, which impacts it horizontally. When we are talking about the bullet, the more feet per second we can retain per yard, better it is. That means it's slowly down as a rapidly rate. That means it gets to the target faster. Has less drop due to gravity and less deflection due to wind. Less drop and deflection means more accuracy. We want to be able to predict how fast or how much a bullet is going to drop due to gravity or deflection due to wind. Magnus effect. Magnus effect generation of a sidewise force on a spinning cylindrical or spherical solid immersed in a fluid, liquid or gas, when there is a relatively motion between the spinning body and the fluid. Named after the German physicist, a chemist H.G. Magnus, who first experimentally investigated the effects in 1853, is responsible for the curve of the serve tennis ball or a driven golf ball that affects the trajectory of a spinning artillery shell. The Coriolis and Eötvös effects. When talking about ballistics, the Coriolis effects refers to the deflection on the trajectory of the bullet generated by the spinning motion of the earth. Its effects is negligible at medium distances, but becomes important around 1,000 yards and beyond, especially because it can add to other minimal errors and keeps off target. Despite being associated with Coriolis, I'm probably butchering that, and I apologize, the phenomenon that actually affects the vertical component of the trajectory is called the Eötvös effect. The rotation of the Earth generates a centrifugal force the same that pushes you to the side when you make a sharp turn in your car. This force acts perpendicular to the Earth's rotatory axis, I apologize, adding to a subtracting to the gravity force. Next, we have vertical angles. When a gun is sighted in a level on or nearly level ranges and then ID'd fired either uphill or downhill, the gun will always shoot high. The effect is well known among shooters, especially hunters, but how high the firearm will shoot is subject to considerable controversy in shooting literature. In fact, at the present time, some literature has some information that is simply erroneous. The next one being transonic ballistic performance. Long-range rifle may seem to be capable of delivering accurate shots at every possible distance, but they have a limit, the transonic region. When the bullet exits the muzzle of a high-powered long-range rifle, it generally travels at a rate of 2 or more times the speed of sound. And so, bullet speed in these cases is therefore considered supersonic. When the bullet flies supersonic, it compresses the air in front of itself, generating a series of shock waves that origin from the bullet tip and propagate behind the bullet as a cone. My name is Matthew Johnson, and I hope this helps. Thank you very much, and have a good day.